All right, so our question is store a univariate polynomial using a singly linked list, right? And our univariate polynomial that is given to us is I guess it is this one, 5x cubed minus 6x squared minus 3x plus 2. Okay, first of all, we need to understand the two terms, right? What are univariate polynomials? And what is the other term? The other term is singly linked list. Singly linked list. All right. So when we say univariate polynomials, it is those polynomials with only one variable. So if you see this polynomial, you see only one variable, that is x, right? So that is why this is a univariate polynomial. We have another variable like y, z, or something else, it will not be univariate. It will be another type of polynomial. All right. So just because of the fact that we have only one variable, x, right? This is why it is called univariate polynomial. And in a polynomial, we have this coefficient. What are coefficients? Coefficients are, let me change the color. Coefficients are these numeric values, all right? And we also have exponents, right? So what are exponents? Exponents are these ones. You see? These are the exponents. This one, these are the exponents. All right. So first of all, we need to be clear with all these terms. We have in a polynomial, we have a coefficient, and then we also have exponent, and then we also have signs, right? Here we see plus and minus, plus, minus, okay? So these are the properties of polynomial, right? Now, then we see another term, singly linked list, and the question is asking us that we have to store this in a singly linked list, right? So how is it possible that we can store this in a singly linked list? Okay, so I have already defined what a univariate polynomial is. Singly linked list is as we have talked about, singly linked list is a collection of different nodes, right? There can be n number of nodes. You can say this is one node, second node, and this can be the last node, n number of nodes you can have. And we have said that singly linked list contains data in the first block of the node, and in the second block of the node it contains the address of the next pointer, right? So wherever this address is pointing, this pointer will point to that place. All right, so that's what we have known. And I have also talked about this important thing in a singly linked list, that singly linked list is about connecting of different nodes. They are not interconnected, all right? There's a difference between interconnection and connected. These are just connected nodes, all right? Okay, now we are clear with our singly linked list, but then you are having a doubt that how can I store these univariate polynomials in a linked list, right? So it's very simple. You can also store linked list also supports mathematical computation. So you are able to store coefficient, okay? Just as what we've mentioned in the properties of this. You can also store exponents, and then you will have to store the next pointer, right? These are the datas, and this is what you do. You is very much important in linked list, right? So now I'll show you how you can visually represent this univariate polynomial in a singly linked list. I think I can erase this. Let me take a screenshot of this just in case. Is there a screenshot option to do that? Hello? Okay, so I guess it's not possible. All right, so whatever it is, I'll just take the picture of this. Okay, now we have just explained about what is singly linked list, and now we have to learn how can we store these univariate polynomials in a singly linked list. All right, so let me erase all of this first. Okay, now storing this in a singly linked list. Okay, so how will we do that? As I have said, in a singly linked list, we can store the coefficient. First of all, what is important is the number of nodes, right? As we have said, this node, this node, this node, and this node, and so on. There can be a number of nodes, okay? So nodes, the number of nodes is important, then the coefficient is important, and we have the exponent, and we have the next pointer, right? Okay, so let's make this as one node, second node, 3 node, and 4 node, all right? So let's fill this up. Let's make it just in a form of a table. Let's make this in the form of a table and do it like this. Yeah, let me change the color again. Yeah, let's use green. Okay, so at node number 1, we can store this, okay? Yeah, leaving behind this, okay? Yeah, so at node number 1, we are at node number 1, okay? So as I have said, coefficient is the numerical value, right? So we have to store this data in the first node. What's the coefficient of this? 5 is a numeric value. And what is the exponent? Exponent value is 3, right? That's the power. And what will be the next pointer? The next pointer will be the next, yeah? The address of the next. So we'll have, here we are, taking the addresses 1, 2, 3, 4, we're just assuming. So our next pointer will be 2. Simple. Then we are done with this one, okay? We are done with this one, and we are going to the next pointer 2. So our current node is here at 2. And what is our next thing? We are encountering this one, right? So it will be -6, yeah? And the exponent will be 2. And the next pointer will be 3. Okay, so now we are at this current node, and it will be 3. And after that, we have reached till here, right? So it's -3x, -3 is the coefficient, and the exponent is to the power 1. Yes, it's to the power 1 because x to the power 1 is x, right? So it will be 1. And Somebody has stopped my recording. Somebody has stopped my recording. Somebody has stopped my recording. Oh my God. All right. So let me continue with my screen. Where is my whiteboard? All right, so let's continue with that one. I think it got deleted. So whatever it is, so our equation was, I think it's 6x cubed, I guess, minus 5x squared, then minus 3x plus 2. I guess this is our question, right? And I hope the recording is still going on and it's not deleted. So I hope it is still there. And I'm going to continue with that, all right? So this is what our table is. We have the node and we have the coefficient. And then we have the exponent. And we have the next node, right? Okay, so as I have said, these are the nodes, right? Here we have 4 terms, right? That's what I did, I guess. So at the first node, we'll be storing this. Second node, we'll be storing this. Third node, we'll be storing this. And at the last node, we'll be storing this, yeah? Then first node, we are here. Coefficient is a numeric value and the exponent. And the next node would be what? I said we'll take this as 1, 2, 3, and 4, right? So next node is 2. And then where the next, this is done. Yeah. And again, we have this node that is, just a minute. Somebody's calling me. Okay. So next we are at the second node. Okay, this stores the current node, all right? And the coefficient here is -5. And then we have the exponent 2. And the next node is 3. So this is done. Yeah, because no, this is not yet done. This is done. We're at this third node now. Okay, so it's a -3 and x to the power 1 is 1. Is x. So our power is 1, and next is the fourth node. Okay, so we're at the fourth node, and we have the coefficient 2. And here x to the power 0 is 1, right? So we'll have the exponent as 0 over here. And when there is no other data to be stored, the last node we usually write it as null. I guess you remember that, what I have taught in the class. Okay, so this is how you store a univariate polynomial in a simply linked list. All right, so how can you write this? You can this is a graphical representation of the node. So you can also make it like this: 6, 3. All right, 6, 3. Then pointing to the next, and then -5, 2. Then you have -3, 1. Then you have 2, 0. Yeah, so what is this? Doesn't this satisfy 6x cubed, right? And this one satisfies -5x squared. And this one's -3x, and this one is there is no sign for this plus now, so just 2. Okay, so this is how you do it. Okay, that's it. And all right, I'll share this recording with all of you.